I'm Chris Ray, and I'm going to show you how to draw the Mandelbrot set in Excel. On the way to the Mandelbrot set, we're going to use 3 Excel dark arts: Iterative Calc, Relative Reference to Find Names, and Alphabetic Worksheet Calculation. I'll explain those 3 later, but now I'm going to try and explain what the Mandelbrot set is. The Mandelbrot set is the set of complex numbers C for which the function fcz equals z squared plus c does not diverge to infinity when iterated from z equals 0. I've no idea what complex numbers are. You can't write them down, can't do anything useful with them. Really, they're only of interest if you've got a level 70 World of Warcraft character and can prove beyond reasonable doubt that you've never been in a romantic relationship. If you're not a mathematician, the Mandelbrot set is some sort of formula that can make cool patterns. The patterns repeat infinitely, so you can zoom in on an area and continue to see more detail. Similar structures will repeat as you zoom in on the set because of some sort of mathsy thing to do with the square root of -1, which doesn't exist. The Mandelbrot set is named after Benoit Mandelbrot, but he didn't invent it. It was invented by some other mathematicians called Brooks and Metelsky in 1978 in this rather riveting-looking research paper. Both Brooks and Metelsky had max-level Warcraft characters at the time, though back in 1978 the level cap was only 60 because the Burning Crusade wasn't out yet. Benoit Mandelbrot came into the picture 2 years later when he was working at IBM's Thomas J. Watson Research Center in New York, and noticed that this function actually made pretty cool pictures that normal people could relate to. Mandelbrot probably didn't know as much as Brooks and Metelsky did about complex numbers, but he certainly knew that pretty pictures get you research department funding. To draw the Mandelbrot set, we could enlist the help of a mathematician to turn this formula into some actual instructions, but I've already insulted mathematicians twice, so Wikipedia is. Fortunately, Wikipedia has a whole page called Plotting Algorithms for the Mandelbrot set. It means plotting as in drawing, not plotting as in scheming. Stake time algorithm, squares of real and imaginary parts, and a list of instructions. What we're going to do now is turn this pseudocode into an Excel sheet and pass it off as our own work. And we're going to do this without using VBA or any other macros because that's what God intended when she created Excel. It looks like the pseudocode runs 50 times for each pixel in the grid. On each iteration, it performs a few mathematical operations. It stops either when it meets a specific criteria or hits a maximum number of iterations. The value in that pixel is the number of iterations we got to. Our first problem is that the loop runs 50 times. Normally, if you want to do something 50 times in Excel, you fit your calculations into one row, and then you create 50 more rows. But to generate the Mandelbrot set, we want to loop 50 times for every square in a grid, and we can't easily do that in rows. For this, we're going to use our first Excel dark art, Iterative Calc. Iterative Calc basically allows you to take the results of your spreadsheet, feed them back into it, and calculate it again. It's not a new feature, it's existed since Excel 2 in 1982. In fact, I think I can remember... Well, here we are back in 1982. I'm 7 years old, badly photoshopped, and inexplicably have a PC and a copy of Excel 2. To use Iterative Calc, you'll first want to turn calculation to manual so you can decide when the iteration starts. From now on, you'll use F9 to recalc the sheet. Once you've turned it on, you can use previous cell values and calculations. This means there's no such thing as a circular reference in Iterative Calc. This number in my spreadsheet will keep going up forever if I keep pressing F9, so I'll introduce a reset flag. That's a cell that can be either true or false. True means reset the model and start at 0 again, false means run the model as normal. If we wanted to run this model 100 times, we could just hit F9 100 times, or we could tell Iterative Calc to use a fixed number of iterations. And back into the present day. Iterative Calc is great for job retention because the more spreadsheets you can make with Iterative Calc, the less your employer is able to fire you because nobody else knows how they work. Our pseudocode needs to run 50 times, so let's turn on Iterative Calc with 50 iterations. On a parameter sheet, let's establish some input values. The extent of the set specified in the pseudocode is x from -2 to 1 and y from -1 to 1.5. Let's define that region in our spreadsheet by giving it a top left xy coordinate and a square window to extend down and to the right from that. Because our sheet is going to use Iterative Calc, let's make a reset flag so we can set the model back to its original state. Now we've got all our inputs, let's make defined names for them. We can do this easily by highlighting the full range of labels and values then hitting Ctrl-Shift-F3 and telling Excel to take the names from the left column. There they are in the Define Names dialog. Now let's make an output sheet where we'll keep the final iteration count for each cell and eventually render the Mandelbrot set. Each pixel in the image will be represented by one spreadsheet cell, and I'm going to start off with a 20 by 20 grid. We're going to need to know the XY coordinates of each of these pixels on our grid, so let's give them some. The pseudocode defines x0 and y0 to be the pixel coordinates scaled into coordinates in the Mandelbrot set. We'll use x0 and y0 a few times, so let's create define names. To convert an x coordinate in the pixel grid to an x0 location in the Mandelbrot set, we can first add the x left position and then scale the x position. That's coming out as -2 in the top left cell, so it looks good. However, our column indicator B1 is an absolute reference, so unfortunately this scaling will work great for the top left cell in the grid, but as you can see, Excel will still return -2 for the other grid columns as well. This brings us to our second Excel dark art, relative reference define names. To make x0 evaluate correctly in other columns, we'll turn the column portion of this define name reference into a relative reference by removing the dollar. One easy way to switch between absolute and relative references is to highlight the reference and then press F4. It'll cycle between locking the row reference, the column reference, or both. When you put a relative reference in a define name, it adjusts according to the referring cell. This means that in the define names dialog, references are shown relative to the cell that you had selected before you hit Ctrl F3. Now that we've made B1 a relative reference, you can see the scaled x values changing from 2, 1.85, to 1.7, depending on what grid column we're in. Now let's define y0, which is just the same scaling, but for the y-axis. We can tell that we've done the scaling approximately right, because the top left is at -2, -1.5, and the bottom right is close to 1, 1.5. I realise we're currently on line 2 of the pseudocode, but I'm going to pick up the pace shortly. In the core iteration loop in the pseudocode, 3 things happen. First off, xtemp gets set to something, then y gets set to something, then x gets set to xtemp. For each pixel, these 3 steps keep happening until one of 2 things occurs. Either x squared plus y squared is greater than or equal to 4, or we hit the maximum number of iterations. Once we've hit one of those exit conditions, the output value for our cell is the iteration count. Let's make separate grid sheets for each of the 3 steps. We'll call them Calc xtemp, Calc y, and Calc x. From the pseudocode, we can see that these steps need to be completed in order. This leads us to our third Excel dark art, Alphabetic Worksheet Calculation Order, for want of a better name. Normally Excel just works out the calculation order for your spreadsheet and you don't need to worry about it, but in iterative calc mode, where one thing can equal the other thing and vice versa, you need to have some order to calculate the worksheets in. And the way in which Excel does this is alphabetical order. And you can't blame me for this because I was on the Excel team 25 years after that decision was made. So to make sure Calc xtemp, Calc y, and Calc x are computed in the right order, we'll put them in alphabetical order. Let's prefix Calc xtemp with a 1, Calc y with a 2, Calc x with a 3, and finally our display sheet with a 4. In order to use x, y, and xtemp in calculations on the various sheets, let's define yet more relative reference define names for them too. I'm doing this partly because I like tidy formulas, but mostly because once you've got a taste for relative reference define names, you'll find yourself wanting to use them constantly in order to assert your Excel dominance over everyone who tries to edit a spreadsheet you made. Now we've got define names for x, y, and xtemp, let's populate the relevant sheets with the calculations for these variables. Xtemp is pretty simple. In here we just put equals x squared minus y squared plus x0 from the pseudocode. Y in the pseudocode is equal to 2 times x times y plus y0, but it gets zeroed at the beginning. We'll do this by checking for our reset flag. And then we can set x to xtemp with a reset, and we've got the 3 core mathematical operations from the iteration loop. I've no idea what any of these calculations really do. If you're interested in the details, then I suggest you get onto Tinder and try and find someone who knows more about imaginary numbers. Nope. 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 Lastly, we have to populate the display sheet. The final result for each pixel is the number of iterations that pixel used. You will recall, of course, that the exit criteria for the loop was either that x squared plus y squared was 4 or more, or the maximum number of iterations was hit. We don't need to check for the maximum number of iterations because Excel is calculating the whole workbook 50 times whatever happens. We just need to stop iterating when x squared plus y squared is 4. We need an if error in here too, just because sometimes x squared plus y squared can become too big for Excel to handle, and we don't want our display sheet to fill with pound nums. That's us finished. We can now recalc the sheet with the reset flag turned on to reset the model, turn the reset flag off, and recalculate once more to generate our first Mandelbrot set. If you're a mathematician, you're probably quite excited to see all these numbers now, but the rest of us might need something a little bit more. To make these cells look a bit more like pixels, let's first resize them to be square. Let's also get rid of grid lines and apply an empty string custom format to our cells to stop them from ever showing anything. Finally, let's apply a 3-color scale conditional formatting rule to the values. Our pixels are still a bit big, so let's change the column width to 0.19, the row height to 1.3, and let's increase the size of our sheet from 20 by 20 pixels to 600 by 480 pixels. Now we've got some very small cells, so let's reset the model and run it again. To look at different areas of the set, we can just enter different values on the parameter sheet. And we can experiment with different colors just by changing the conditional formatting rule. That's us pretty much done. You can download the spreadsheet below if you'd like to play with it yourself.